So my name is Maggie Lakomy. I am a third-year graduate student doing research in developing new methodology using metal catalysts in Giri's lab over in the Penn building. So my goal ultimately at the end of this degree is to go and become a chemistry professor teaching organic chemistry.
So when did you know chemistry would be your primary field of study? And also, was there a specific class, experience, or thing that you did as a high school or undergrad or sometime in your life that helped you decide?
Yeah, so my journey to figuring out chemistry as my primary field of study was a little bit backwards. So when I came to my undergraduate university, I started as an education major focusing on secondary education for chemistry. I knew I liked science. Out of all of them, I was like, chemistry would be the most fun one to teach. And so I started out the first 2 years taking all my chem courses and then taking all my education courses, and was kind of in two different worlds between those two. And then sophomore year, I took OChem and I fell in love with it. And I realized I never wanted to leave OChem. I wanted to keep doing it. I was so excited. And I was like, this is the part of chemistry that I really, really want to teach. And so that led me into, okay, I'm going to switch my major. I'm going to focus on chemistry. So eventually I can go get a doctorate so I can be a professor. And then I started doing research at an undergraduate lab at Ohio State, Dr. Burkett's lab. It was super awesome. And I also fell in love with research with that.
Nice. Yeah. So next question would be, how does chemistry and in particular the research you're doing apply to people's everyday life?
So the way my chemistry applies to people's everyday life is a little bit more distant than maybe some of their labs, but I still think it's super cool and interesting. And so what my lab and what I focus on doing is using transition metals to catalyze new reactions. So we can make new types of bonds and structures that we haven't been able to make before, or they've been really difficult, or it's hard to apply. And so our goal with that is kind of with two different approaches. The first one being thinking about pharmaceuticals and med chem, and if we can make new products, maybe we can find new drugs to treat diseases, or maybe something that was really difficult to make, now it's a lot easier to make, and so we can help make a lot more of it for people. Additionally, on the other side, we look into things like materials. So that is stuff like nanotubes and things that we can apply for optoelectronics, and how we apply these kind of reactions there, how can we help improve life that way?
Question is, what makes you excited to come to your office or lab every day?
So there's the two parts of that. The first one is the research. I love coming in, and oftentimes with my stuff, a lot of it runs overnight. And so I come in and I'm like, okay, get the data, put everything on the different instruments, let's figure out what happened. And from there, planning out my day, what worked, what didn't work, talking with my lab mates through some stuff and being like, what do you think about this or like that? And working on it and getting to see this new information and see all of it finally coming together, especially, at the midpoint of the project, it's just you're in different hurdles than you were at the start. So it's interesting to experience all that. And the other side of what I do is working as a TA. I love coming in and going back to basics and working with students and seeing them get excited about the same things I'm excited about, and seeing those moments of oh, this is how it works in the lab. And oh, there's my product. I made it. It's a crystal and it's pure. That's awesome.
All right. And then last question for me is, how has being a researcher enhanced your personal life?
The way that research has enhanced my personal life, a lot of times I just think of it as having more confidence in the way I move through the world, and knowing that if I can tackle all of these things in grad school and all these problems in my research, then we can I feel more confident in what I can do as a person and how I can help my students, and even just learning new problems and helping other people solve their problems.
Awesome. So my first question is, in honor of Women's History Month, who was your most influential role model, who's a woman in your professional life, and why did you choose this person?
So for me, my role model when I'm thinking about chemistry and women that I've met in chemistry is kind of ends up being two people. The first one was my high school chemistry teacher, Mrs. Heinrich. She's the one who introduced me to chemistry. It was the first time I experienced it, and taking her two chemistry courses and getting to like have those labs and really learn about it, and having a woman, because we had a lot of women science teachers at my high school. It was really great to see them and see that there was someone who was excited about this. And then talking with her how I was interested with chemistry, she was excited and was thrilled to see someone else go into the field. And then once I started research, I was working with a graduate student named Kenzie Mason, and working with her and having that mentor and being in that research lab and having someone I could look up to and talk to, especially as I started to get ready to go to grad school and do all the applications and take the exam and all that stuff. Having those people and seeing that people like me can do this, we belong here, and having that sense of community was really nice.
Awesome. And then my second question is, what is your most unforgettable memory from your career in chemistry? And so like a couple examples: conferences, presentations, events, maybe even friends that you made. But like, what's the most memorable thing that you've seen in the field?
So for me personally, the most memorable moment in chemistry was in my undergraduate research. I was in an organic materials, if I can say the words correctly, lab. And organic materials is focused on basically large structures that are mostly made of organic, so like carbon and hydrogen and all that good stuff. And one of the things we would do is when we'd make these large materials, you could actually look at them with things like TEM. And so I made a compound and we self-assembled it. So that's when you essentially like different intermolecular forces cause it to assemble into a structure. For us, it was nanotubes, and making those and getting to use the TEM for the first time and see, oh, I'm running this really cool machine and I'm seeing, like literally seeing the nanotubes that I made, was just a moment of, this is so cool and interesting. And I never thought this was something I'd be able to do. And so from there on, like there's been more moments like that, but that was the first one.
Cool. And then my last question, do you have a favorite Nobel Prize recipient of all time? Preferably in the chemistry field, but also outside as well.
So my favorite Nobel Prize recipient is not actually someone who has won it, but someone who definitely deserved it. Rosalind Franklin was the one who did all of the work and the calculations to discover the structure of DNA, that double helix. However, as probably we've all learned somewhere along the way, the two men who published it and got all the credit stole her work. And if you look up and you look Nobel Prize winners and you put like Nobel Prize women chemistry, if I remember right, there's like 7 of them. And the reason why there are so few is because we have this history of not recognizing women's work, let alone a lot of time of not letting women in the field. And so looking at someone like that, who didn't get the recognition that she deserved, but contributed so greatly to the field, and all of her work was really interesting. So for me, it would be her.
Awesome. So now I have a couple questions. What is your most cherished chemical element?
I am an organic chemist. I feel like it was required for me to say that my most cherished element is carbon.
Yeah. And if you weren't working in chemistry, what career path would you have taken?
If I wasn't working in chemistry, I would be working in education. I would probably be teaching chemistry. If you want me to say no chemistry at all, I would probably be teaching English, because that's like, I love books, I love stories and reading. So that's probably where I would have ended up if I didn't go down the science route.
Yeah. Now, this question is geared more towards research. If you weren't working in your current field of research, what field would you be focused on?
If I wasn't working in organic chemistry research, I'd probably be looking into more biochem. It was always something I thought was interesting, understanding like how things work in your body and diseases, and all of that was something that I never got into very heavily because I took organic chemistry and I ran with it, but that would have been probably a second.
Awesome. These last 2 questions are focused around teaching. So if you could teach any class not chemistry related, what would it be?
Probably back to going to something with the literature, like looking at interesting books, especially ones that I've enjoyed, and maybe like looking at like more modern stuff and how that affects, especially like if you look at things like new mediums like comics are always interesting to see.
Awesome. And then if you could teach any chemistry elective, what would it be?
So the chemistry elective that I actually want to make, and I hope someday when I'm a professor that I can do this, is making a chemistry elective that covers organic chemistry and specifically is like an elective. It's not going in like super deep like we would go in like our typical like 210 and 212, going in and making it applicable to people's lives. Because a lot of times I've seen in other science areas, they have these courses that are designed for non-majors who are not anywhere in the sciences, but to fill those gen eds and to get them interested and explore. A lot of the times chemistry is viewed as this big scary thing and, oh, I could never take that. And then we look at people who feel later on in life like they don't understand chemistry, they don't feel comfortable, they feel nervous. I want to design an organic chemistry course that welcomes people in and shows them how cool our science is.